Hi everyone. In this video I'm going to talk about correlation analysis and describe two different tests for correlation, the Pearson product moment and the Spearman rank order. You do each of these tests depending on which type of data you are trying to test correlations for. So correlation analysis can determine the sturdiness of two linear relationships between two variables. So we can only show association, and remember that correlation does not equal causation. So some more spurious correlations. More iPhones means more people die from falling downstairs. The possible causative element here as people would require people to be using their iPhone while walking downstairs, but the fact that more iPhones in the market doesn't necessarily cause people to fall downstairs. And the per capita consumption of high fructose corn syrup is negatively correlated with the spending on admission to spectator sports in the US. So the only explanatory variable here to explain the correlation might be that the more high fructose corn syrup people are eating, the less interested in sport they are. There is no apparent causation between the two. Two things can happen together, and they can happen opposite to each other to suggest causation that might not actually exist. So our two tests for correlation, the Pearson test and the Spearman test. Know the difference between the two, because if you don't do the right one, you'll get rubbish as an output. So the Pearson product moment correlation coefficient. Again, say that 3 times quickly. So the Pearson test is a measure of the strength and direction of a linear relationship between two metric variables. So that is the key here, in the fact that we're dealing with either variables that are on a Likert scale, or they're on a ratio scale, or some other kind of metric scale. When the correlation is strong and significant, then the variables are associated. So our null hypothesis here is that the correlation coefficient is statistically significant, and the null hypothesis is that the HO is that there's no association. If it is not significant, then it has no meaning, so there is no association. So the correlation ranges from -1 to +1. This relates to that X and Y axis we saw previously. So if you follow my cursor here, if it is a 1, it is a perfectly linear. If it's a -1, we are in the other direction. So we talked about having a positive relationship being that way. When it is a perfectly positive relationship, we are simply going up and down. If it's a perfectly negative relationship, then the opposite is true. So our SBS procedure for a correlation test is shown on the right. I will do this in my Delhi Depot data. So to do a correlation or a Pearson correlation, we need to go analyze, correlate, bivariate. And the two metric variables I'm going to correlate are recommend to a friend and satisfaction. So X8 and X9. I then select options, and I select means and standard deviations, continue, and OK. So here is our correlation output. So this is what you'll see in SPSS. I'm going to show it to you in my slides so I can show you more easily what to look at. So in terms of the analysis, there's pretty much only one stage to a correlation analysis. We look at our correlations table. So what we see here is that our Pearson correlation, this number just here, and also it's the same here, is 0.61, and the significance of this is 0.000. So we conclude that satisfaction level and recommend to a friend are correlated because it is less than 0.05. In addition, the coefficient of determination, which is R squared, or the Pearson correlation squared, is 0.601 squared, which equals 0.361, i.e. that is 36% of the variation in recommend to a friend is explained by the variation in satisfaction level. So when we continue on and we look at regression, it is the R squared that we look at in regression that is based on this correlation test that is produced by an R in the Pearson correlation. You might also notice that 0.361 is the same as our R squared linear line statistic that is produced by SPSS when we include the plot line in our scatter plot diagram. So that is the Pearson correlation. Next, I'm going to look at the Spearman rank order correlation. So in this one we are dealing with different types of data. They are no longer both variables being metric. So in a Spearman rank order correlation, at least one of the variables is ordinal in its scale. So that means that we have a rank order or some other ordinal type of scale included in the data set. So again, it's a measure of the strength and direction in a linear relationship between two variables. The SPSS procedure is as follows. So we go to Analyze, Correlate, Bivariate. I need to reset my correlation because I'm using completely new data and a completely new test. So I need to look at my variables of x15, which is this one, which is I'm going to look at both of my variables being ordinal. So both of these were both x15 and x16 were measured on an ordinal or a rank scale, where one is where you had to say which one is more important: friendly employees, competitive pricing, speed of service, etc., rank from 1 to 7. I go to options. Oh, no I don't. Ignore that instruction. Basically, on this correlation coefficients underneath the boxes, I need to unclick Pearson and click or select the Spearman. I leave everything else as is and I say OK. So our Spearman output looks like this. It's called a non-parametric correlation. The reason it's non-parametric is the fact that I'm dealing with non-metric data. So in order to show you the analysis, I'm going to go back to my slides. So similar to the Pearson correlation, what we need to look at is the correlation table. And in this case, our correlation coefficient, or our R, is negative 0.495. So we know we have a negative correlation or a downward slope between food quality and food variety. And our significant two-tailed is 0.000. So again, it's below 0.05. So we say that we have a significant negative relationship between the two variables. So the interpretation of this is that a customer who ranks food quality high in importance tends to rank food variety significantly lower. So if you want to be perceived as, for Deli Depot, to be perceived higher to have higher food quality, they might need to reduce the number of food items that they are producing or offering. So additional analysis is also required here. So we need to compare the importance of factors. So we need to do our frequency tables and include the mean in the output. I'll just trust me, the instructions are there. I want to make this video as short as possible because there's a lot of tests to run. So the interpretation of this output is that the highest mean is the most important factor, because 6 is the most important and 1 is the least important. So if you look at our table down below here, we see that food quality is the most important factor in people's choice of restaurants. So we can conclude that food quality is the most important factor in Deli Depot's customers' choice of restaurant, and the market area is the least important factor in Deli Depot's choice of restaurant. If you look at where food variety ranks, it is also quite low down the list. It is third last. So you could you'd need to run additional tests, but you could say that, conclude that Deli Depot definitely should reduce the number of food items it offers in order to get people to perceive it as having a higher food quality. So in the next video, I'm going to talk about testing for associations in relation to making predictions between variables.